Welcome. So, one of the more, or at least a little bit harder topics to understand with simple interest is this topic of equivalent values. And I thought I would make this video maybe to try to help you a little bit so that you can give it some thought on some key terms and then provide a couple of examples for you that you can dwell on and see if you can really understand the concept. So, the word equivalent means the same. So, if you take and compare two items, two values in this case, so maybe the values are in money, the question is, are they the same? Are they equivalent? Well, being the same is easy to understand if you have $100 with you and somebody else has $100 and you're talking between each other, and I guess that $100 that both of you have is identical to the $100 that someone else might be holding. So now, with these equivalent values, the question is, well, if this happens on the same date, well, then that's nice and very easy to compare. If someone has more money than somebody else, then I guess you can, easily deduce that if you have 100 and somebody else has maybe 200 today, so that is, the $200 is a little bit bigger. But all of this relates and must be compared on the same date. Now, when you do compare things on the same date in terms of money, we like to call this a focal date. So something that you want to compare, so a focal date, because it may not necessarily be today. Maybe you want to compare things 1 year from now on this particular day and then see if the two money are still being equivalent. Now, as you know, well, with simple interest, or interest in general, it doesn't have to be simple interest, it can be compound interest. Now, with interest, if you start applying interest, your $100, okay, so this value is going to change over time. So, if you have, let's say, 5% interest, then in a year from now, this 100 at 5%, it's going to grow by 5%, and you will have no longer 100, but you will have $105, where that extra $5 came from the 5%. Now, this interest rate can also change. It doesn't have to be 5%. It can be 1%, 3%, 10%, or whatever other amount. And obviously, depending on the percent, this value, okay, will change for us. So I like to kind of compare things and draw them out on a timeline for myself. So if I have, for example, this timeline going, and if this is, for instance, now, so today, and let's say that I have, let's divide it up, and let's say this is 3 months from now, and let's say this is 6 months from now, and then maybe 9 months from now, okay, and then this would be, let's say, 1 year from now. So now if we come back to this original example, okay, so that you are comparing the $100 right now, well, they're equal. But, if you now come along and you say that, okay, well, Jason over here has $100 today, and let's say Joanne maybe, okay, at 9 months, okay, down the line has 100, and you want to compare these two, and you want to check if they're equivalent, if they're the same. Well, if there is no interest, okay, so if interest is 0, for instance, then indeed it doesn't really matter, okay, because the money would just continuously be $100 and it wouldn't really grow in any way or depreciate in terms of its amount that or buying power that it has. But as soon as you would change this, and we can again make it simple, let's say it's 5%. Now, so if you say that you now have over time, there's a concept of time value of money, meaning that money is changing over time at this 5% rate. Well, then the $100 now that we have, and then the $100 at 9 months from now, is most likely not going to be the same. So what we like to do is we like to pick, as I pointed out over here, okay, so we like to pick this focal date. Now this focal date you can choose yourself, and it can be at any point in time, but it has to be a particular date where you're going to be comparing two or maybe more values in time. So just for the sake of it, okay, there's a very easy way we can pick today, okay, to be a focal date, because we already know that the $100 today is worth $100 because it is today. And then the $100 at 9 months we would have to bring back to today. So we would have to carry this back in order to see, okay, what that $100 at 9 months actually is, okay, today. And we can pick this 5% right here, okay, as the time value of the money. Okay, so what we'll do is we can say, okay, so today will be our focal date, so our comparison date between the two values. And since we are bringing money back, okay, so whenever we do that, if we take money from the future and then we try to bring it back into the present or into some other point which is at a different time, then what we do is we use our simple interest formulas. There are kind of two of them that we have. We have the one for our future value, so again, P is our present or principal, R is our rate, and that's our annual rate because we have simple interest, and T is the number of years that we have. So this would bring money into the future. Okay, so now we're bringing this $100 right here, not into the future, but from the future back. So we're going to have to use the present value, which is just a manipulation of the formula above, and that's going to be your future value, or the sum value. That's why I'm writing S. Okay, so S stands for sum value, so the addition, sum, okay, of your principal plus your interest. Okay, and very often this is just simply referred to as future value. And that means that our formula Okay, so it's going to be that. And this is when we bring money backwards. So our arrow goes back. And then the one above is when we bring the money forward. So now here we're bringing money backwards, the $100. And so what we can do is, so I'm going to use this formula right here, okay, because I am bringing money back, the $100. So the present value, okay, right now of that $100 is going to be, okay, so I'm going to substitute it in. 5% is simply 0.05. And now I am bringing it back, okay, so from 9 months to now. So I'm just going to write it here on the side. So t is equal to 9 months, but we need t in years. So it's going to be 9 divided by 12. Okay, so we have, so 9 divided by 12. And now we can calculate this and see what happens to that $100 over the 9 months. Okay, when the time value of money is 5%. So let's take out our calculator here. So I'm going to just punch this in. So I have $100 and divided by, okay, so I'll open my bracket, and it was 1. Okay, so plus 0.05 times, and that was 9 over 12. Notice I'm using the brackets, okay, and then I'm going to hit equals, and notice that it's less, and it should be less because there was an interest of 5%. We're bringing money back from the future until today. It's not going to be a huge difference because it's 5%, but there is a difference. So as you can see, it turns into $96 and, well, rounded 39 cents. So 96.39. So here we have 96.39 rounded. So now we can talk about equivalent values, meaning I can take the $100, okay, that I had today. So I was supposed to compare 100, okay, and then the 100, which was, this was now, and this is 9 months away, which really turned out, as we did the calculation, to 96.39 right now. So this 100, 9 months from now, is equivalent, it's the same as $96.39 right now. That's what we mean by equivalent values. That these two are equivalent. They're the same. Now, numerically they're different, but because of the 5% interest, they're the same. It's exactly the same amounts, just at different points in time. And now clearly, okay, so if I'm comparing, then this 100 is actually bigger, okay, because it compares to this 96.39. So I wanted to give you this introduction kind of at a slow pace so that you can watch it and understand these equivalent values as you're shifting them around. And you can shift them anywhere you like, meaning you can take this focal date that we have, okay, so right here, and you can move it anywhere. And so you can take the 100 from now and you can move it to 3 months, to 6 months, a year, and you can find its equivalent value. But it has to be equivalent at a given rate. So that's what has to happen. Okay, so with that introduction, let's take a look at a neat example here. So we'll use these equivalent values, okay, so meaning moving, okay, amounts at different points in time. And this is what we have. So in this example, Chris is owed payments of 350, which is due today, okay, and 700 due in 6 months, and 618 due in 1 year. So let me just draw this. As I said, I really like to utilize, okay, timelines just so that I can see visually what is happening. So we have this timeline. Now we are owed payments, okay? So we are owed these payments. Now 350 is owed to us today. Okay, so that's today, whatever day that might be. And now, so that's this one. 700 is due in 6 months. Okay, and then 618 in 1 year. So I'm going to just draw here. So this is 6 months from today. And then this would be 1 year, which is, I guess, 12 months. So 1 year, which is 12 months. So at 6 months, okay, we're supposed to get a payment of 700. Okay, and here at 1 year, we're supposed to get a payment of 618. Okay, so that's what Chris is owed. Now, Chris has been asked by Mauro, who's the one owing him the money, that he would like to simply just give Chris one payment in 10 months from now, with interest allowed at 15%. Okay, so it turns out, okay, so that these values right here that we have, so these are a debt to Mauro. Okay, he's supposed to pay this, but he doesn't want to pay in 3 different payments. He is saying that he just wants to pay one time, but instead of paying, 350 today and 700 in 6 months and 618 in 12 months, he's saying, well, I just want to pay you, okay, a one payment basically, but I want to pay it, okay, so right here at 10 months. And now, of course, we don't know what that payment is. So he's saying that he wants to make this payment, okay, at a rate of 15%. Okay, so the time value of money, so the time value of money, okay, is this 15%. Now, what does this represent right here, this 10 months? Well, that's a focal date. It's a focus date where what we want to do now is we want to try to see, okay, what all of these 350, 700, 618, what are those equal to, okay, at 10 months? Well, the only way to do that is we have to find their equivalent values at 10 months. So what is the equivalent value of this 700, okay, dollars? What is the equivalent value of the $618? And then what is this equivalent value of this? Okay, $315. Well, these are all debt, right? And we want to find the repayment for these. If there was no interest, you can just add these amounts and you know exactly how much Mauro would have to pay. But because there is an interest of 15%, I can't just simply blindly add them. I have to move the values to 10 months, and then I have them at the same day, which is the focal date, and then I can add them and see how much Mauro would actually be paying in one payment. So let's do that. So that number 1, okay, so right here, so I'll do this just once. So we have our rate is 15%. Now our time, t, which is supposed to be in years, well, that's from 6 months to 10 months. So in total, that is 4 months. And now we can't write 4 because we want t in years, so it's going to be 4 divided by 12. That's for that. Now, notice that this arrow right here, okay, so what we're doing is we are shifting, okay, and our arrow is forward. And from the introduction, okay, whenever you have an arrow forward, okay, we are going to use our future value because we're moving, okay, this into the future. So we have S is equal to, so P, okay, 1 plus RT, and now we have to substitute the correct amounts. So P is $700, and we want to find its equivalent value at 10 months. 1 plus, well, 10 months is 4 months away. Okay, and as I said, this would be 4 over 12. And close my bracket, equals. So let's see what that gives us. So we have 700 times, okay, so open bracket, 1 plus 0.15 times, and it's the 4 months, okay, so divided by 12, and that's $735. Now, does that make sense? Of course it does. Notice it is more than 700. So what this is saying is that $700 at 6 months is equivalent to $735 at 10 months at a 15%, okay, time value of money. That's what that means. So, but we've just found 1. Okay, so we've done 700. Now we have to do the same thing for the other 2. So I'm going to change color so that it stands out a little bit for us. So for the second one, the rate doesn't change. The time does change. Okay, so for number 2, okay, which is 618, if you look at the chart, notice that t is, okay, right now it's at 12 months. And I want to bring it back to 10 months, which is 2 months. Well, 2 months divided by 12. And now the question is, well, do I use the future value formula or do I use the present value? Well, I am moving from 12 months to 10 months, so I am bringing it back. So whenever we bring things back, well, we're going to have to use our present value formula. So that changes for us a little bit. Okay, now let's substitute that in. So I have 618 divided by 1 plus 0.15 and 2 over 12. Notice I always keep my time as a fraction. Okay, I'll just let the calculator take care of it. Okay, try not to change it back into decimals, especially if you have running decimals, okay, that go on. And then just use the calculator to find out what the answer is, which is what I'm going to do now. So we have 618 divided by, okay, so I'll always open the bracket when it's that fractional division. Okay, and now 1 plus, so 0.15 times, okay, and then it was 2 months, okay, so over 12. Okay, close the bracket, and we get 602.93. Okay, so we have here 602.93. All right, so now that takes care of this. So that means that $618 at 12 months is equivalent to $602.93 at 10 months at this interest of 15%. Those two values are equivalent. Now the last one that we have, so that I'll put here is number 3. Okay, so we have this 350, and now we have to shift that from today all the way up to 10 months. Okay, so now t, so r stays the same, but t is 10, okay, over 12. And now, again, am I moving it into the future or am I moving it back? Well, clearly I am moving it from today into 10 months from now. So I'm going to use S is equal to P 1 plus RT, and that equals, and now I can put it all in, so 350, that's my value for the present value, 1 plus 0.15, and finally we have T, which is 10 over 12, and now we can punch it into our calculator. So we have 350 times, open bracket, 1 plus 0.15, okay, times 10 divided by 12, close the bracket, okay, and equals, which is 393.75. So 393.75. So again, this now means that $350 today is equivalent to $393.75 10 months from now. So what will Morrow have to do, okay, now that we know the three values, we know our first value, we know our second value, and we know our third value, well, we now have to add these up. So we have to take these three and we're going to have to add them up to try to find, okay, what the repayment would be at 10 months. So repayment at 10 months at 15% would be, so 735 plus 602.93 plus 393.75. And now we can get our answer, okay, once we add all of these up. And then Chris can decide, does he just want this one payment at 10 months, okay, or if he does not want the one payment. And that's all that we would do. Okay, so this would complete this particular question. Okay, so I can leave that calculation. Okay, so let's plug it in now. Okay, so hopefully I'll try to remember. Okay, so we have 735, okay, plus 602.93, okay, plus, let's go back. So 735, 602.93, and 393.75. 393.75. Okay, so 1,731.68. 1731. Okay, so 68. That's how much that one payment would be. Okay, and that completes this particular example. All right. I hope that this helps you so that you can kind of dwell and understand the concept of these equivalent values, okay, and moving them around. So do remember some key concepts. Focal date, okay? Focal date is the day that you are comparing things to, and then you're shifting things at a time value of money at a certain percent. Okay, and as you're shifting it, if you move it into the future, you use the future value formula. And if you move it to the present, you move it back, you use the present value formula. All right?